Let us continue our discussion about AVL3, specifically how to insert values in an AVL3. So let's have this example. We're going to insert 14, 15, 16, 13, 12, 11, and 10. Initially, we don't have any value in our tree, so therefore, 14, when we insert 14, it will be the root node. And then 15, when we insert 15, it will be the child of 14 on the right side. And now we are ready to insert 16. So it should be inserted on the right side of 15 as a child node. And let's check if the balance factor is valid or not. So for 16, it's 0. 0 minus 0 is 0. While for 15, node 15, 0 minus 1 is negative 1. While for 14, 0 minus 2, it's negative 2. So therefore, this is not an AVL3. So we need to rotate. We need to do something with our binary tree. So let's check the source of the error for node 14. So node 14 is connected to the left side, to the right side rather, so which is 15, and child node is connected to 15 on the right side. So therefore, we need to implement an RR rotation to make this binary tree as an AVL tree. So for RR, we're just going to locate for the middle node between these three nodes, which is 15. And this 15 will be the new parent node, and 14, 16 will be the child node of 15. So when we implement this scheme, the result will be this. And when we check the BF, all values will be equivalent to 0. So now we are ready to insert a new value. So let's insert 13 and 12. So when we insert 13, it should be inserted on the left side of 14 as a child, while 12 will be inserted on the right side, on the left side of 13 as a child. And let's check if the BF is still true as for AVL. So 12, 0 minus 0 is 0. For 13, 1 minus 0 is 1. For 14, 2 minus 0 is 2. So we have a problem with node 14. For node 15, 3 minus 1, 2. So we also have a problem with node 15. And 16, 0. So let's start solving first node 14 before 15. Okay, so node 14, let's check what is the source of the issue with node 14. So a child is connected on the left side of 14 and a child connected to node 13 on the left side. So therefore we have a LL. So we need to apply the LL rotation scheme. So we're going to look for the middle node between 12, 13, 14, which is 13. This will be the new parent node between these three. 12 and 14 will be the child node. So this will be the result. 13 will be connected to 15, 12 will be on the left, 14 will be on the right side of 13. And now we are ready to insert more values. So before that, let's check if the VF are already accepted as for AVL3. Yes, all VF are okay. So this is already considered as AVL3. So now let's insert 11. 11 will be inserted on the left side of 12 as a child node. Let's check if all BF are still okay. So for 11, 0 minus 0 is 0. 12, 1 minus 0 is 1. 13, 2 minus 1 is 1. And 14, 0 minus 0 is 0. 16, 0 minus 0. But for 15, 3 minus 1 is 2. So we have a problem with node 15. So we need to have a rotation. So let's check where is the issue, what is the cause of this issue. So it is on the left side. So 15 is connected to 13, and 13 is connected with 12 and 14, but the issue is on the left side wherein 12 is connected to 11. So that's why we have more height compared with the left on the right side. So we have an LL issue. So LL rotation should be implemented here between 12, 13, and 15. So let's look for the middle or middle node between 12, 13, and 15. So it is 13. This will be the new parent node. 12 and 15 will be the child node. So what will happen with 14? Since 15 should be on the right side and 14 is also on the right side, so 14 and 15 should merge in the right side and check which is higher. Okay, one will be a child of the other node. Since 14 is smaller than 15, so when we connect 14 to 15, or 14 merge with 15, it should be on the left side as a child node of 15. So the result will be this. 13 will be the new parent node, and 14 is now connected with 15. Okay, so let's check if all values, all BF, are correct. So all are accepted, therefore this is already an AVL3. Now let's insert 10. So it will be connected on the left side of 11 as a child node. So let's check if there is an issue with this binary tree. So we have 0, 1. Unfortunately, we have an issue with node 12. We have 2 BF. For 14, 0, 16, 0. For 13, it's 1, and 15, it's 0. So there's a problem node, which is 12, and we need to check the source of the issue. So it's on the left side. So therefore, LL approach. So look for the middle node between 10, 11, and 12, and it will be the new parent node. So 11 will be the parent node, 12 and 10 will be the child node of 11, and 11 will be connected to 13. So this will be our new AVL3. But let's check if it's correct. As you can see, all BF are correct, are valid to be considered as an AVL3. So AVL, balance restored after inserting all the values. Okay, so that's how we implement AVL concept while we insert values in our tree. Okay, so on the next video lecture, we're going to discuss more about insertion. Thank you for listening. See you on the next video lecture.